I'm going to be talking to you today about a study that we did exploring the influence of shared control. But before I get into that, let's quickly talk about how people tend to use partial driving automation or level 2 driving automation in general compared to manual driving. Because we hear a lot of red flags, a lot of hand waving when it comes to, the safety of partial driving automation, and either people emphasize this potential safety or they emphasize the potential risk. And so let's quickly talk about what really happens. When you look at how people actually behave on the road, they tend to actually use it responsibly most of the time. Most of the time, people tend to do what they're supposed to do. However, we do see that in general, when people are using partial driving automation, they tend to drive faster. They tend to look away from the road more and for longer. And they also tend to multitask more, especially with non-driving related secondary activities. So this really does raise the question of how can vehicles be designed in a way to keep drivers engaged from the get-go? I know a lot of you are involved in the sensing and response in terms of countermeasures for driver support features, but that's only part of the solution. The other part of the solution is keeping people engaged and doing what they're supposed to be doing from the get-go. And so that's what we're going to be talking today about. Specifically, we're going to be talking about cooperative steering. There's many different names for this. You probably heard collaborative steering, shared control. What this is designed to do is basically incorporate or tolerate driver input while actively providing lane centering support. Now, a few years ago, the IIHS, the Insurance Institute for Highway Safety, came up with a vehicle ratings program for safeguards for partial driving automation. And cooperative steering is one of the categories in that program. And the reason for that is because there is research showing that this is a potentially good implementation strategy to keep people engaged in the driving from the get-go. And so let's quickly talk about what that means in terms of potential advantages for cooperative design. First and foremost, with cooperative design, it requires the driver to be an active participant. It requires the driver to be actively sharing control. And what that does, it actually helps provide a proprioceptive feedback loop. And that means that the driver's getting a lot of subtle haptic cues constantly through their active participation. That in turn actually informs another modality available to the driver to sense what the system, what the vehicle is doing in real time. This allows for faster interventions, more subtle interventions, more comfortable interventions by the driver. This also correspondingly increases just general physical engagement with the vehicle as a whole. And there is early indications that this also helps to reinforce the driver's sense of autonomy in their roles and responsibilities using the automation. Because as we all know, partial driving automation, while it's a combined use of adaptive cruise control and lane centering at its core, it still requires the driver to be actively involved in supervising and intervening when necessary, because at the end of the day, these systems cannot replace the driver. So the other side to this, though, are the pros potentially for a non-cooperative design. It has been suggested that non-cooperative designs, where basically the lane centering support ceases either because it's temporarily suppressed or because it fully deactivates when the driver starts to steer, because the idea is to reduce mode confusion. Mode confusion is when the driver gets confused about what the system is doing and what their roles and responsibility are in that moment. And so the idea here being with a non-cooperative design, when the system is supporting, it's very clear the system is supporting because the driver is not involved. But as soon as the driver gets involved, the system does a handover to the driver to make it clear that they are suddenly involved. But again, this gets murky when you start considering that this is still a partially automated system and the driver should never really relinquish full control. So keep that in mind. But another thing related to this has to do with hands-free driving. You can have hands-free design in a cooperative system. That is possible to do. And in general, though, when it comes to hands-free driving, we see that compared to hands-free driving, when the driver's hands are already on the wheel and they have to steer, they have to make a physical steering intervention, those interventions tend to be faster, They tend to also be smaller in terms of the lateral acceleration and where also the vehicle's positioned on the road. We tend to also see smaller drifts in terms of the positioning of the vehicle when the driver's hands are already on the wheel versus when they go from hands-free to hands-on. And it's likely that cooperative design can help facilitate that because we've seen implementations of this already. So it can be effectively done. But the question I had today was, do consumers really understand the design intent for cooperation or non-cooperation steering-wise in the partial automation that's equipped on their vehicles? So we had a question to have 4 different vehicle owners groups, 2 of which have cooperatively designed steering support, 2 of which have non-cooperative design steering support. And we see, and because you see the good and poor ratings associated here, it's because the vehicle ratings program that I just mentioned rewards cooperative design and doesn't reward non-cooperative design, as you're going to see why. And the 2 cooperative systems that we looked at are Ford Blue Cruise and Nissan ProPilot Assist 1.0, not 2.0. And the non-cooperative systems was Tesla Autopilot and GM Super Cruise. So in terms of the people who actually participate in the study, there's a lot on this page. Basically what you need to know is 2 of these systems were hands-free capable by design. The GM system and the Ford system are hands-free capable by design, and the other 2 are not. We can see that in general, people were middle-aged. That's when the age tend to cluster around. We also see that these people were frequent drivers and frequent users of the partial automation on their cars. So before we jumped into things in the survey, so this was a multimedia survey, and in this multimedia survey, we first show some videos to people to make sure everyone was on the same page when it comes to understanding how people interact with the steering wheel. Because, believe it or not, people have very different expectations of what steering means when you ask someone about what it's like to steer. Sometimes people have even different expectations around what you mean around having your hands on the wheel. So this video was basically to demonstrate the types of interactions people tend to do with their car in general, as well as when using the partial automation. And so the goal here was to show different steering effort levels, different hand contact levels with the vehicle to demonstrate what we're talking about. And I'm going to show you another video that actually we asked in particular about. But this was really just to get everyone on the same page about what is it like to steer within the lane. Note that all these videos that I'm showing right now, these videos only show the driver steering within the lane, not leaving the lane, because the goal here was not to have lane departure prevention or intervention characteristics. We wanted to just focus on the lane centering support of the vehicle. And so the next video that I show you here, this is showing lane line hugging. And what lane line hugging is, it's when most lane centering systems try to preserve the midline. They try to keep the vehicle in the center of the lane as much as possible. And sometimes, as you're going to see later in this presentation, sometimes people want to move over. Some people don't want to leave their lane, but they want to move over a little bit to one side. And so this is what we're showing right now. In this video, you can see that the driver is making an S-curve maneuver, because the goal here was to show people the driver steering actively in the lane to one side, then to another side, to demonstrate basically that the driver was actively steering and departing from the midline while still staying in the lane. So we asked people, once they saw this video, we asked them specifically in relation to this video, when your system, the system equipped on your vehicle, is being used, how does it respond when you're steering the vehicle within the lane like this? And we had 3 different options people could choose from. First option says it stays on and continues to help steer while I steer. And the only 2 systems that do that in this sample are the Ford and the Nissan systems. The other 2 options were it stops helping me while I steer, but automatically resumes once I stop. That was the GM system. And then it stops helping me once I start steering and will not automatically resume once I stop. That is the Tesla system. Sometimes the GM system, but definitively it's the Tesla system that behaves like that. What's interesting about this slide is you can see that the opinions were very similarly distributed, which really shows that people seem to have expectations that can override reality, it seems. But we wanted to ask this in a different way just to make sure it wasn't how we were asking this. So we have another question where we said, okay, which statement best represents overall what it's like to drive while using your system? And the three options were you and the system drive together at the same time. And the next one was it's either you or the system that drives the vehicle, but not together at the same time. And then the third one was a combination of the two. And again, you see very similar distributions of responses, regardless of the design of the system. So another question we had was, so how does this relate to how people respond or think about their systems when they think their systems are cooperatively designed? So here we asked, regardless of the actual design of their system, here we asked, how much do you like the way your system responds when you steer like this? Again, referring back to that video of the lane line hugging maneuver. And if people thought that their system stays on while they steer, they're much more likely to say they like it compared to when they think their system switches off when they steer. So that also was related to the idea of how competent people think their system is as a driver. So this was in relation to, do you think you are more competent than your system as a driver? And in general, when we looked at this, we saw that when people think they are the better driver than the system, they are much less likely to relinquish full control to the vehicle. Whereas if people think the system is the better driver than they are, they're much more willing to relinquish control to that system, which makes sense. Now, we also had a question about that hands-free capability, because we first want to know, do people understand whether their system is hands-free capable or whether they understand it's a hands-on required system? And as I mentioned before, the Tesla system, the Nissan system, those are hands-on required. The other two are hands-free capable by design. We asked this question in two ways. First, for does your system let you drive hands-free for up to a few seconds? And most people said, yeah, it does. And then we asked, well, what about for half a minute or longer? And here we again see kind of similar responses, even among the hands-on required systems. But what was interesting is the GM and the Ford system are actually designed to be used with sustained hands-free capability for certain periods, and that didn't translate into consumer understanding, apparently. And then we also asked, the reason why we asked about hands-free driving habits here is related to how we analyze the data later on that I'm going to show you. This was just to give us a sort of benchmark of where habits around hands-free driving tend to fall. And we see that kind of similar distributions for Tesla and GM and Ford. However, the Nissan owner group tends to be more conservative, and that's something we've seen with other studies as well, other surveys. The Nissan owner group tends to be more conservative, but this most likely speaks more to the owner population rather than the design of the Nissan system itself. So just bear that in mind. We also asked about whether someone's likelihood to use a system hands-free or their interpretation of how competent the system is, whether it's being used hands-free or hands-on. We see that it's kind of mixed. Some people think that their system performs better when their hands are on the wheel. Some people think their system performs better when their hands are off the wheel, but not in a really consistent direction. And so it just shows, again, there's a lot of variability and understanding about how these systems operate and where the roles and responsibilities fall. Now, let's go back. All right, so we want to know also whether this was a potentially situationally specific effect, because here we see a lot of variability, we see a lot of misunderstanding, but we also know that implementations, especially physical ones, tend to produce different experiences for different people. So we want to know, for a given situation that you're going to see represented here, how likely were people willing to share control with their system for the given scenarios I'm going to show? The baseline, nothing's happening. This is the most ideal driving conditions for partial automation. Clear conditions, no cars around, very clearly demarcated lane lines, very straight roadways. And then the uncomfortable scenario has this large other vehicle, which was being driven by one of the employees that we had. So we were talking on the radio when doing these maneuvers, by the way. So this was highly controlled, but that large vehicle basically sits on the lane line separating the two lanes. So it's uncomfortable, but it's not unsafe. Then we see the hazardous scenario. In this case, we see that large vehicle veer in and out of its lane repeatedly before the vehicle recording overtakes it. So this is what the videos look like in terms of the recording. You can see, again, baseline, nothing's happening, uncomfortable, sitting on the line, and then hazardous, you can see weaving in and out of the lane. With the uncomfortable and the hazardous one, basically the vehicle overtakes the recording vehicle overtakes the large vehicle, and then the video ends. Now, in terms of what people saw, so let's look at the Tesla Autopilot group. Here they see basically two video feeds overlaid on each other in a single view. And here we have the video recording of the roadway and then how the automation was communicating in its instrument panel below. And this was basically just to sort of mimic what someone would generally see when they themselves are driving. And the goal here was just to, again, emphasize that the automation was operating at the time. And so everyone saw a display and recording from a vehicle of their owner group. So, for example, the Ford Blue Cruise owners, they saw the recordings recorded from a Mach-E. The Tesla Autopilot, they saw the recordings from a Model 3, and so on. Now, first, we wanted to control responses with respect to how likely people are to steer to one side when encountering these three different scenarios. And we controlled it by asking also what they would do without the automation support, so under manual control. And while controlling for that, we can see actually very clearly that those people with cooperatively designed systems, so the Nissan and the Ford systems, are much more willing to want to steer to one side of the lane than the other in all three conditions. Now, as for how people want to keep their hands on the wheel, what we found was, again, not related to the hands-free driving capability, but again, the cooperability of the system design. Here, we controlled for their normal habits, what they said they do in general when it comes to hands-free driving habits. And using that as our control, we can see that, in general, people who have cooperative systems are a lot more likely to say they want to have their hands on the wheel when in the uncomfortable and the hazardous condition, but we saw no difference among the vehicle owner groups in the baseline with respect to willingness to have hands on the wheel. Again, this is just kind of speaking to a more implicit design that is tied to the cooperability of the system rather than the hands-free capability per se. And so, all right, a quick summary of what I just told you. Basically, most people expect cooperative steering. This seems to be the most pervasive expectation that people have, regardless of the design of their system. And they also tend to prefer the way their system behaves if they think it's cooperatively designed. This kind of speaks to expectations overriding reality. So again, it really does speak to the intuitiveness of a cooperative system versus a non-cooperative one. We also see that actual system cooperability seems to have a more implicit influence, a situationally specific influence in terms of a driver's willingness to share control. And we also see that there is clear widespread misunderstanding around whether a system is designed explicitly to be hands-free capable or hands-on required. So that's just something that isn't really translating in terms of design intent. And we also see that in general, people are more willing to share control if they think the system is a less competent driver than they are. This is something we've seen a lot, especially most recently. So for example, you look at very competent systems like Tesla FSD, incredibly sophisticated, incredibly technologically complex systems. And we see even people who are extremely knowledgeable users of the technology still fall into automation complacency and over-reliance issues that have been associated with severe crashes. So it really goes to show that even a person's understanding and knowledge about a system can still be overridden by expectations around how the system performs. And that in turn erodes the driver's senses of responsibility and their roles in maintaining the safety of the vehicle. So again, this is not breaking news or anything, but it does seem to show that there is a relationship here that is worth better understanding and exploring. And as a summary, this really does help reinforce why the cooperative steering requirement is incorporated in this partial automation ratings program, because again, it seems to be the most intuitive to the most number of people, and it seems to correspond with a greater willingness to share control. So that's all I have for you, and I want to thank you very much for listening. Thanks.
We on here? We have about 5 minutes for questions. Really cool talk. I really love this work that interrogates how drivers think these really complex systems work. Right. So questions out there in the audience for Dr. Mueller.
Hey, my name is Riley Keene. I'm with SPD Automotive. So I'm wondering if, from your perspective, how you feel comprehensive regulation in this space helps inform consumer understanding from the top-down level and dealer education as well.
Very good questions. Okay, let's take the easy one, dealer education first. Dealerships in general, especially in the US, tend to have extremely high turnover. Unfortunately, that means that the training that the staff get tends to not be very comprehensive, if it happens at all. There also tends to be a lot of variability in terms of the technologies equipped in the vehicle lineup that's being sold at the dealership that is also poorly understood outside of partial automation. So the end result is you have people buying vehicles that are equipped with all these technologies without getting really any useful or comprehensive information. Some automakers have approached this issue by having post-purchase tutorial days. Unfortunately, they tend to not be very successful in getting participation because people go, well, I already bought the car. Why would I go again to the dealership to learn something that you should have just told me when I was buying the car? So there's a lot of frustration with that. But again, that frustration stems from a more systemic issue of just the sheer amount of turnover, the limited information access that the staff have, and also the limited information they have in terms of updating. Some automakers are more insistent about how their cars are sold, but again, there's a lot of variability here. And once you get into the used car market, it's a mess. Now, as for comprehensive regulation, this is where things get messy because we're seeing, first and foremost, it's a little too late at this point. Look at all the different vehicles out there that are equipped with different technologies, and we're seeing a huge variety of different implementation. And as you're going to see in the different presentations and panel that's coming up, implementation has a huge consequence on consumer understanding and use of the technology. And so to have sort of overarching requirements that may or may not satisfy a consumer's need for a given implementation, you start having unintended consequences. So that's kind of where the frustration is. And that's why, for example, with our vehicle ratings program, how we approached that issue, we went in a scenario-based requirement rather than a prescriptive requirement. So we had a bunch of scenarios that we had test requirements with respect to outcomes that we wanted the systems to be able to handle, and we evaluated those outcomes rather than prescribing, you have to design your system like this, because no one knows what the ideal partially automated system looks like because there probably isn't a single one. Again, we're probably seeing a huge variety of different implementations, some of which are more successful than others, but how do you regulate that? Well, probably through scenario-based outcomes where even you give the flexibility to the designers to come up with innovative solutions that at the end of the day still have to perform minimum expectations around user performance and understanding and so on. That's probably the direction to go in. Some organizations have not taken that philosophy, so like overseas, so you kind of see the mix, but that's probably where the best solution lies with respect to still supporting innovation and new solutions and new implementations. So I hope that answers your question.
And thanks for that question. And I think with that, we'll thank Dr. Mueller again.
Okay.
And we'll invite our next speaker to the stage. Carmen,
thank you.